What if AI could simulate an entire society? I dove into the latest research to find out. From predicting population growth to modeling economic trends, AI simulation has the potential to revolutionize the way we approach business forecasting. In this video, we'll explore the concept of AI simulating society and how it could be applied to business modeling and forecasting. We'll discuss the latest research in the field and provide a step-by-step guide on how to use these concepts in your own business. By the end of this video, you'll have a clear understanding of how to use AI simulation to improve your business forecasting and make more informed decisions. The concept of AI simulating society is based on the idea of creating a virtual replica of a real-world system. This can be done using various techniques, including agent-based modeling and machine learning algorithms. Agent-based modeling involves creating virtual agents that interact with each other and their environment, mimicking the behavior of real-world systems. For example, in a simulation of a city, agents could represent individuals, businesses, or organizations, and their interactions could simulate the flow of traffic, the spread of diseases, or the growth of the economy. By analyzing the behavior of these agents, researchers can gain insights into the underlying dynamics of the system and make predictions about future trends. One of the key benefits of using AI simulation in business forecasting is its ability to account for complex interactions and nonlinear relationships. Traditional forecasting methods often rely on linear models that assume a direct relationship between variables. However, in real-world systems, relationships are often more complex and nonlinear. AI simulation can capture these complexities and provide a more accurate representation of the system. For example, in a simulation of a supply chain, AI agents could represent suppliers, manufacturers, and distributors, and their interactions could simulate the flow of goods and services. By analyzing the behavior of these agents, businesses can identify potential bottlenecks and optimize their supply chain to improve efficiency and reduce costs. To apply AI simulation concepts to your business modeling and forecasting, you'll need to identify the key components of your system and create virtual agents to represent them. This can be done using software such as NetLogo or Repast, which provide a platform for creating and simulating complex systems. Once you've created your virtual agents, you can define their behavior and interactions using rules and algorithms. For example, in a simulation of a marketing campaign, agents could represent customers, and their interactions could simulate the spread of information and the influence of social networks. By analyzing the behavior of these agents, you can gain insights into the effectiveness of your marketing strategy and identify areas for improvement. Another important aspect of AI simulation is the use of machine learning algorithms to analyze the behavior of virtual agents. These algorithms can be used to identify patterns and trends in the data generated by the simulation and to make predictions about future behavior. For example, in a simulation of a financial market, machine learning algorithms could be used to analyze the behavior of virtual agents representing traders and investors and to predict the future price of stocks and bonds. By combining AI simulation with machine learning, businesses can gain a more accurate understanding of their systems and make more informed decisions. In addition to its applications in business forecasting, AI simulation can also be used to study social phenomena and understand the behavior of complex systems. For example, researchers have used AI simulation to study the spread of diseases, the growth of cities, and the behavior of social networks. By analyzing the behavior of virtual agents, researchers can gain insights into the underlying dynamics of these systems and identify potential interventions to improve outcomes. For instance, in a simulation of a pandemic, AI agents could represent individuals, and their interactions could simulate the spread of the disease. By analyzing the behavior of these agents, researchers can identify the most effective strategies for containing the outbreak and reducing the number of cases. To get started with AI simulation, you'll need to have a basic understanding of programming and data analysis. You can use software such as Python or to create and simulate virtual agents, and to analyze the data generated by the simulation. You'll also need to have access to a computer with sufficient processing power and memory to run the simulation. Additionally, You can use cloud-based services such as Google Colab or Microsoft Azure to run your simulations and store your data. Once you've set up your simulation, you can start experimenting with different scenarios and analyzing the results to gain insights into your system. One of the challenges of using AI simulation is the need to validate the results of the simulation against real-world data. This can be done by comparing the predictions made by the simulation with actual outcomes, and by refining the simulation to improve its accuracy. For example, in a simulation of a supply chain, you could compare the predicted delivery times with actual delivery times and refine the simulation to improve its accuracy. By validating the results of the simulation, you can increase your confidence in the predictions made by the simulation and make more informed decisions. Another challenge of using AI simulation is the need to communicate the results of the simulation to stakeholders. This can be done by creating visualizations and reports that summarize the key findings of the simulation, and by presenting the results in a clear and concise manner. For example, in a simulation of a marketing campaign, you could create a report that summarizes the predicted response rates and conversion rates, and presents the results in a clear and concise manner. By communicating the results of the simulation